everybody. We appreciate you spending the time here in the next 40 minutes with us. We have a great panel, a great topic, really focused on the augmented worker, and of course, so many new things happening just this year, the past 6 months. But we also want to kind of explore the journey that the augmented worker's been on and where we think it's going to be going. We have an awesome panel, and let each one of them introduce themselves. Starting with Conrad Komarski.
Hi everybody, my name is Conrad Komarski. Can you guys hear me?
Yes.
This is hard to do. I chair the AI Innovation Consortium. It's a collective industry academic group started about 4 years ago with universities from University of Houston to Rio de Janeiro State to University of Ottawa and some new ones in Europe, and as well as several different industry folks, including some of the people you see here collaborate on breaking barriers of adoption of AI.
Right. And Deepak Singh.
Yeah, hi. Myself, Deepak, I work with telecom company Clara. I build AI-powered telecom solutions that reaches from some Manhattan City worker banker to somewhere deep inside the, let's say, villages of Wellington. Right? So that's what I do. I like to learn things, and that's why I'm here. So possibly will be.
Thank you. And next we have Jody Mellick.
Hi, I'm Jody Mellick, and I am a designer, creative technologist, and strategist. I work on the next generation of human-machine interface to AI and automation, or autonomy, I should say. I am currently acting CTO of a stealth space company, as well as a steering committee member for Partnerships AI Committee on Shared Prosperity. And I also am CEO of a company called Superhuman. I'm spoken with superhumans, not supercomputers.
Oh, wow. Nice to hear about that. And next we have Jay Migliaccio.
There we go. That's right. Hello, everybody. My name is Jay Migliaccio. I am a product manager. Currently, I'm working with at IBM as a technical product manager on a new product we're bringing out, which is focused on digital labor, which uses AI and automation to augment knowledge workers' day-to-day activities. Before then, I worked at here in the Bay Area with a few successful startups, helping bring Linux from a consumer product into an enterprise product at SUSE Linux, and more recently at Aspera, where we have helped media companies transition their physical media supply chain into digital media supply chain, so enabling the Netflix of the world to stream content to your homes.
Thank you, Jay. So throughout the session today, we're going to kind of go in some logical order. We're going to start out with the augmented workforce. What does it mean? We go down some technology tracks because obviously technology is centric to this augmented worker. Then we're going to come back on how is it going to impact people. So, and everybody really wants that answer. How is it going to impact their lives, their work lives? So first, I want to start out with the panel and really talking about what do you see as the main business drivers for the augmented workforce. So maybe we start with
I'll
Jay.
take the view from the vendor. What drives business, I think, is maybe the general question. And what's true for driving business is true for driving augmented workforce in businesses is the need to innovate. This is a constant in our economy, the way the economy is structured. Businesses need to continually innovate and compete, and that's no different here with augmented workers. When we get a little bit more granular and understand, what is the augmented worker technology bringing to help customers? It can do a few things. It can help you provide services more efficiently. It can help you expand to new customers and offer new services, and it can also help you expand to new markets and new market opportunities. So those are some of the general business drivers that I see driving the technology effort.
Great. So I'd like to open it up to the panel to maybe expound on that.
I'll take it from a little bit of a different lens. The technologies that have evolved, artificial intelligence, computer vision, mixed reality hardware, are enabling what are traditional problems with solutions that were never there before. Quality inspection, if you're in manufacturing, there's a good amount of people attending meetings in manufacturing. has traditionally been done with a lot of insight from domain experts in it. And augmented workforce technologies can address challenges and provide untapped insights that previously were not something that you could do because either it wasn't cost effective to do or it just simply wasn't feasible, right? So there's an evolution of technology where the business driver is actually, these problems have always been there, and now we can solve things that we couldn't solve before or we didn't do it very efficiently.
To build on what Conrad said, I think there's another way of looking at that same perspective, which is that it also allows us to solve problems that were never able to be solved before. So not just the traditional problems of quality control and things like this, but also problems that there was never a market to solve because the cost was too high to actually go after solving that problem. So this creates new markets, new opportunities to go after because it just was never, you were never able to get into that problem space because of the cost of there.
It's not just about the evolution of the tech, but in fact, in part, the evolution of the tech has been able to reduce the cost of some of the need to deploy something like Edge AI replaces complex, heuristic hardware technologies that are potentially multi-million-dollar. Now it's software, right? So that in turn enables these use cases.
Which is especially important in markets that there's nobody that is owning that market right now because there's been such a cost barrier to entry into that market. So it creates brand new markets that enable all kinds of innovation, kind of like what you're working on, right?
Yeah, exactly. So maybe you can give it a little bit of computer plans. For example, one of the major benefits is scale. Currently, we are having shortages for coaches or like therapists or therapists in general in the United States. And if we bring these technologies and get through the FDA approval, it can scale pretty fast. Like overnight, thousands of members who are not getting the help before, and I say members because in healthcare industry they call it members, otherwise the general word is the users. So till this time, they had to wait for at least a week or two to get a consultation, and now once it is scaled, they can get a consultation with the AI-powered technology in like 5 minutes. And we are already seeing the results. I think a couple of weeks back, I saw this result where the ChatGPT was able to come up to human-level empathy and actually surpass the accuracy of data that it was providing to a user in terms of how to deal with the mental health situation. That was just a trial as an example, but that's what we see already.
Great, thank you. So, kind of building on that, what do you see as the maybe the types of jobs that are going to be maybe disrupted, maybe those that be less likely to be impacted? Obviously, workers want to know. Workers of the future want to know, right? Where should they head? So, Jody, you want to lead off on that?
Sure. This is an area I spent a lot of time looking at. So prior to the work I'm doing now, I was a tech advisor to the CTO of Microsoft, working on AI and enterprise type of experiences. And one of the things we found by talking to a lot of manufacturers and people deploying AI in industry and enterprise is that even though they try to go full on to autonomy or AI, there's actually a lot of jobs that AI is just not designed to do. And what it comes down to is that AI is fundamentally different than human intelligence. And even though we use parity metrics to discuss the effectiveness of AI, it creates a false sense of what AI is capable of. So I like to think about James Evans from, perhaps you know him, from University of Chicago's Knowledge Lab, and he calls AI more akin to alien intelligence, not that it comes from aliens, but that it's a fundamentally different type of intelligence than humans, and that it's a statistical logic, as opposed to humans that are kind of messy, and we think kind of not so logically sometimes, and that's our strength when it comes to partnering with AIs that are so statistically logical. So when it comes to manufacturing, right, we see a lot of applications for pretty predictable types of tasks, and a lot of times we refer to these as rote tasks, but they're really very structured environments, very structured activities that are incredibly repetitive and very, very accuracy driven. But there's still a human being that has to transfer the manufacturing object or something from one cell to the next cell, because that's so messy and there's so many different variables that come into that. So if we extrapolate that into the future, what we see is that these very statistically relevant, very constrained, very structured environments are places where we can apply AI. But in that messy application to reality, let's talk about, say, in plumbing or in surgery or in construction or electrical work, right? Where you encounter a lot of really unstructured environments, very unpredictable environments. What you'll see is more of augmented intelligence, where there's a human collaborating with an AI to solve a real world problem that can't be solved very well by either one individually. So then we start talking about augmented judgment. And we start to look at the ways that humans currently use power tools or other types of tools, where the tool is rather dumb and the human is applying the intelligence about the environment. So now you'll have a tool that can learn, and you can apply it and is smart, and you have a human applying it to novel situations that tool was not capable of doing on its own.
When you look at, so I agree with all that. And I'll say, I think the elephant in the room, for those of you that have maybe not dove deep into the world of artificial intelligence, is GPT. And I hear a lot of, if you've ever used it, it is very compelling, right? It still does, it has a little bit of an issue with actual facts. It convinces you it's a fact, but it isn't necessarily a fact, like especially with quantitative data. So it sounds very convincing, very articulate. And if you look into it, sometimes it gets it wrong, and you can challenge it and it'll correct it, but it'll pretend like it never got it wrong. And that technology, it can potentially serve as a domain expert at some point when it becomes evolved. But I think the whole concept of like augmented workforce is that in fact that it's augmenting somebody's day-to-day activities. Like you said, like all the core of discrete AI technologies, right? Computer vision, natural language processing, it's all about enabling something that humans don't do a very good job or don't really want to do. Siphoning through millions of lines of text is not something somebody wants to do, but AI does a great job, right? So I think to create a quick sound by that is there is a potential for this technology to drive to a place where maybe it becomes a real threat, but I think that anytime in the short term, it will still continue to complement us and really do tasks that we don't want to do until 2025. And how that future looks like, I think, with every technology, you have to reinvent the workforce to address changes in evolution of the workforce. There's nobody in mining here, so I'm going to use this analogy. The mining industry in North America isn't what it was 67 years ago, right? Like globalization, technologies have opened up new markets. So you don't want to send your children necessarily to become a miner anymore. This isn't 100 years ago. So and I work with academia a lot, they're building in industry tracks that train people how to not just work in tech, but how to work with complementary understanding of tech to perform their day-to-day jobs, like in manufacturing, like in all this. And those are the places in the next 10 years that are the real low-hanging fruits, the real value cases sit in those areas, not in we're going to replace the oil rig worker with a robot, right?
Right. That's what I was trying to say, is that it's not that they're sure, as with every industrial revolution that we've seen up until now, jobs change. They don't necessarily go away, but net new capabilities are enabled by the tools that we apply to that job. And so I think in this case, it's very, we're going to see that in a way that we haven't seen since the first or the second industrial revolution, and that's really exciting, right? Because I really like this book called Becoming Superman, and it's inspired by the Stephen Coulter, and it really isn't about AI, but what it talks about is how humans, when they get a new capability through a tool, they create net new capabilities because of that tool. And the example he uses is extreme sports and the kicker. Okay, and the kicker is the thing that, like, when you're doing a ski jump, you launch yourself off into the air and do your jump. Well, up until the kicker, what would happen in ski jumping is that the skier would have to be so amazing and leaping into the air that's where the focus was how do I leap into the air? But once the kicker became introduced, now it wasn't about getting up into the air, it was what do you do once you're in the air? And that's when net new capabilities start to come, because the first jumper was able to do a 360 flip in the air, which was like unheard of. And then somebody saw that and said, oh, he did a 360 flip. I'm going to do a 720 flip. And then somebody saw that and said, I'm going to add another spin and another spin. And so that's where we're at right now, is that these tools are going to create this kind of reduction of the prerequisite skill to be able to do a task. And then it becomes, what do we do now that we don't have to build up that prerequisite skill? What do we do once we launch ourselves off of that kicker?
So you can the courage to actually put on some skis. So, and I think I'm literally not super good.
Yeah, thank you. That's great. So I want to maybe bring it back over to Deepak, kind of building off that, maybe diving into some of what are the technologies that are really impacting the worker, and this was broadened up from it's very easy to go to ChatGPT and AI as the key one, because we're all seeing it today, but we've also seen a journey of the augmented worker over the last decade.
So, first, to the previous question that you asked, like which are the industries that are heavily impacted, and it is all is the answer. But some of them which we can already see that it has impacted is manufacturing, education, and content creation. Right? It is already kind of AI is being used and disrupting these industries by large. I mean, I can think about 10 years back when I was in college and I was doing a project and I was thinking about the Microsoft HoloLens and how it can help, let's say, bike manufacturer in envisioning how the parts will look like when it comes together. So it has already started disrupting from, let's say, 10 years back, I would say. Now, giving it again a healthcare angle, I would say, coming back to your question again, what are the technologies that are impacting now? So now we are already seeing RPA technologies, which is already a history. Like it's past now. RPA technologies, robotic process automation, has been there for a very long time, and it has been already automating a lot of mundane and repetitive tasks. That does not mean it decreased jobs, but actually it increased jobs. Now the technologies that we are seeing which are disrupting is again AI-based computer vision and natural language processing technologies. Giving it a healthcare angle, let's examine a scenario when someone comes to an emergency room and the doctor wants to judge the current state of the user or of the patient and the past state, how they have been doing in their healthcare journey, and then make a decision based on that. The doctor just has, let's say, 5 to 10 minutes to make that decision based on whatever data they had. Now, using both computer vision and natural language processing technologies, they can have a summary, an AI-generated summary, which is already vetted from before that yes, this technology works, and the doctors can ask questions about the members directly, in natural language, and then in just 5 minutes, the doctor will have more precise decision than they would have ever taken before. Right? They can get these scores of what is the best possible next step for this particular patient in this particular scenario. So that is where I see that a combination of natural language and computer vision can be really disruptive in a positive way in healthcare and in any other industry. And we have already started seeing that.
Yeah, so maybe leading off of that, open to the panel. Is there examples of increased productivity, improved metrics that we can tie to? Because at the end of the day, we all don't want to live on the hype curve of ChatGPT. We need to see real world results, especially when we're in things like healthcare, industrial markets, and whatnot.
I'll take that one. Again, coming from the perspective of a vendor providing AI and automation-based software. Another technology, which I think has delivery results today, is when you combine AI and automation software to automate your workflows. And the example of this is in the large organizations today, there's many processes and applications and systems that our knowledge workers have to process to be able to get their work done. And there's a lot of manual steps to complete those tasks. So by presenting the workers with the right information and the right context at the right time, they can become more effective. And I often think of the world in terms of technology stacks. Let me share the story vision with you. The current business world today, when I look at business workflows, it reminds me of building manual computers back in the day before we had cloud computing. And there's all these components you had to put together to actually make a computer. And then fast forward a few years, and we had standardized computers that came shipped out of the box, and you could get a standardized operating system out of them. And from the standardized operating system, the Linux one is where I heritage is. We were able to assemble not just computers, but all kinds of infrastructure automatically and create cloud computing. So through the advent of standardized components, we were able to create, in automation, we were able to create cloud computing with composable infrastructure. And then moved up the stack a little bit to composable platform as a service, where you could allocate not just storage or memory or networking or compute, but you could allocate databases and web services and other platforms as a service. And that the composable infrastructure allowed us to create higher level applications such as software as a service. And then we move up the stack and we see software as a service, which is now built primarily in the automobile with APIs, and the software itself is composable. And the point of that story is we're at a point in the business world where those business processes are now becoming very composable. And I think when you take AI that has the knowledge and context of the business process and automation, clever automation tools, we can create a lot of efficiencies. And we've done it at IBM actually. We're starting to use digital worker technology to enhance the productivity of our own employees.
So I think it's important to decide what metric we're using to define productivity here, because when it comes to shared prosperity and computing, we look a lot at the economics of these technologies and how they're improving economies across the globe. And one thing that we're finding is that it is increasing productivity for individualized companies, but maybe not necessarily for GDPs, right? So we're seeing a leveling out of GDPs, what's GDP? I keep forgetting. Gross domestic product, right? So we're seeing a lot of countries are actually seeing a decrease in their GDP because of the fact that they have built their economies on human labor, and some of these technologies are being used in the short term, in the near term, as human replacement. And when we look at the kind of the long-term forecast of how some of these technologies can be applied, human replacement is one portion of their application, but then there's other types of applications, such as like when we're talking about Asian manufacturers. A lot of the Asian manufacturers I'm talking to that are based on cheap human labor, what they're seeing is that they'll lose the benefit that they have, the like competitive advantage of cheap human labor, but they'll be able to gain mass customization, which they weren't able to do prior. And so they'll be able to deploy those workers in these mass customization applications. So it's difficult to determine. You have to really set what metric are you using to determine whether or not it's increasing productivity. And in some cases, companies have tried to go too quickly to full autonomy or to full AI deployment, and have actually seen a decrease in their productivity. We saw that at the Tesla plant. Of course, this is an old story, you've all heard this, is that they tried to go too quickly to autonomy, realized that it actually was causing all kinds of things. They realized the lesson that GM had learned 20 years prior and said, oh, whoops, we need to have those human workers here because they do essential jobs that we really need those workers to do. So it really depends on what metric you're using to determine whether or not it's useful.
So I will not go anywhere. So with is there certain, and I'm going to bring it back to AI now, is there certain forms or types of AI that work better with humans? And which ones do you see evolving? So if you have that, right?
I'm going to take from my predecessor and I'm going to quickly talk about the other points. So you talked about connectivity and you introduced yourself as part of like the value proposition, which earlier, which was everyone from like San Jose to Wyoming, right? So connectivity, microgrids, storm resilience, those are game changers for governmental workers, right? Those create a lot of information flows. And in terms of the value, one term I'll use to kind of summarize it is, to me, augmented workforce is essentially technologies that elevate workers to the complexity of their tasks. And so you can map that out, different types of technologies that do that to support some process. And as much to answer your actual question, I think, and I think some of my colleagues might be able to complement this discussion, is AI in operational environments isn't trustable unless it's explainable, unless it's open. There's a lot of platforms, some of which I see here, that make it a point to, when you're using AI as a mechanism to augment the workforce, that it is providing you with insights how to make that decision, so that you as a domain expert, using that knowledge, can just override it. And it is everyone that I've worked with in the workforce itself that is handling critical systems doesn't want something telling you, hit the red button, and that's it. It wants to, you want to understand why you have to hit the red button, right? So that would be one that comes to mind.
Yeah, so to that point, I was listening to a podcast a couple of days back about descriptive AI and then interpretable AI. So two things, and that concept is also new to me. And what I gathered from that the first one is about, let's take an example, that again, the emergency room example, right? From healthcare side, like this example again. Let's say a patient comes to the emergency room and the AI system is able to tell that, okay, this is the background, this is the next best action that should be taken based on the background of this particular user. So that's just telling the results and giving the suggestion. That's just descriptive. Interpretable means if the system could tell how it came to that conclusion. If the system could tell, I used these particular features and I assigned this particular feature as highest, like for example, the age or the patient is diabetic, like these are the highest valuable features that I assigned highest weight to, and then I came to this result. So that will actually help the doctor in understanding or validating the result for that matter. That okay, whether the result is good or should I make my own decisions. Also, it will help in learning in the background. That okay, these things are important to decide what's the next step. So maybe and this is not true. So let me ask for a retraining of the model to reduce the weight of the age from this model. Right? So it can be used to make decision and understand if that decision is valid. Plus, it can be used to retrain the model and make it more effective. That's okay.
So we'll keep moving. I see the 10-minute sign start to come out. Let's move to our third topic on adoption and kind of what does the future hold. So maybe first, what are some of the barriers, and also where do we think we're at on this augmented worker maturity curve? So, Jay,
Yeah, I think in terms of barriers, the first and foremost one I think we alluded to earlier is trust, right? So we know you can open up ChatGPT and ask a question, but you also know you can't exactly trust it, right? And if we're going to take that technology and use it for professional work, we have to know that we can trust it. So I think things like trusted AI and trusted large language models are an important barrier to adoption. The other one I would say is a little bit cultural. I mean, the technology is there to do amazing things today. I think about my own adoption of new technologies, and the one that started in my mind was when we're moving from paper to paperless office environments. And for many years, the PDF format had existed, and for many years, I was able to get my paycheck in PDF format, but I always wanted that paper version because of a cultural reason. I identified value with that piece of paper. I've been liberated since I decided to go with paper-based paper. But it was surprising to myself how important culturally that piece of paper was in a couple of weeks when I got my paycheck. So I think those are cultural elements to adoption as well.
I would also add that a lot of when I was working with Microsoft, and we were trying to help deploy AIs into companies, one of the things we found was a lack of skilled workforce in enterprise environments or industrial environments where you have a lot of specialized skills required for deploying and developing AIs. And that learning curve, that prerequisite knowledge is starting to come down, but it still requires a team of specialists that aren't exactly cheap. And the other thing is structured data. Right now, all of this, like ChatGPT and some of these OpenAI solutions, as well as some of the things from AWS and Microsoft, they require you to have supervised learning, they require very structured data, and 98% of most corporate data is completely non-structured or structured in completely non-analogous ways, so it's very difficult to go through and retroactively deploy that type of stuff. I think the other thing is the usability of the tools. You mentioned HoloLens. I was one of the principal designers of HoloLens, actually, so I think shut up. Yeah, but I think that one of the things we're talking about is that the HMI that we use to interact with AI today is very much based on a linear binary compute, and so graphical user interface GUI, which we all use, is really defined to sit and wait for the human to command, and then it takes action. But what we're talking about is a whole new way of computing with AI because it's statistical. It's dimensional. The data is dimensional. It has weights that the AI is giving that data, and we have no way of understanding that in our current human-machine interface metaphors. So one thing that we are really on the cusp of is how do we create that next version of how humans interact with it. And so I like to say a lot that augmented reality is to AI what the monitor is to the PC. And so we need to have that change also made where it's all about human training of AIs in situ, as opposed to right now where it's like sitting back and pushing a button. It's more an engagement loop of the human and the AI.
Okay, Clara, real quick.
Let me give you one AI example and one AI example. So I think for artificial intelligence specifically, these are new horizons. So in manufacturing, oil and gas, healthcare, there's a lot of regulatory components to making this adoptable at scale. I'll throw an example out of my field. There's American Petroleum Institute has legacy ways in which they define inspection. Those standards, and that goes for manufacturing, automotive, et cetera, healthcare, et cetera, are not open in many cases to this concept of completely automating and disconnecting the individual, potentially, from some of the decision process. So your efficiencies that you can gain from augmenting the workforce in part sit at the table waiting for compliance change. So there's a whole spectrum of things in that area. Now, in a non-AI form, like when we talk about augmented workforce, one of the things that I connect to, because it's such a broad term, is connected workforce. It's mixed reality, HoloLens 2, which we can come and take a look at if you like, sign it with a felt pen. So to me, those technologies, right, to get into industrial environments also have to evolve. And I met with some mixed reality hardware people recently, and one of the things they're finding is like, I want to get into this space, but I don't have these compliance requirements to safely operate it. And I don't have economies of scale to go into it. There's plenty of use cases for it. So the barriers, and ergonomics is another one, although I do like the ergonomics of the HoloLens. There are others that I don't like. And I'm trying to be nice. But
I would say that the ergonomics are a big problem.
yeah, right. So adaptability, wearing this thing for 10 hours, 8-hour shifts, the battery life. I mean, there's evolutions of technologies that have to take place to make this adaptable at a scale, along with compliance, along with platforms that can harness those augmented workforces also at a scale effectively, right? Because it's one thing we give one person a HoloLens versus I have a fleet of 1,000 people going into a connected plant, and each of them now operates a HoloLens or a mixed reality hardware or augmented hardware. So there's grid, wireless grid, microgrids that have to be installed. There's a whole slew of barriers. But the technology, I would say, is there, right? It's just there's a landscape of things that have to take place to make it adoptable.
Okay, so we're getting
Compounding
pretty
expansions.
So I want to move on, but before we move on, are we in the first inning, the third inning, the sixth, the bottom of the ninth? Where are we at?
Depends who's ready, I think, right?
Second inning.
Second. You're saying in terms of the adoption?
Yeah, maturity and adoption.
Yeah, I mean, it depends on the industry, right? It depends on your definition of augmented workforce. But if you're talking about the state of the art, like AI, I would say the second, third inning.
We're crawling. We're not moving.
Okay. All right, so we're going to move. We have 5 minutes or a little less. So now we're going to speed date. So the people
That's
factor.
what I signed up for.
People love to hear about the people. So should workers be concerned? Are they going to be displaced next year? We hear a lot of hype. It's not going to take more than a year before some industries are totally disrupted.
Depends on the reskilling curve.
Yeah, so short answer, maybe a 30-second answer would be during industrial revolution, the concern was same and it turned out to be good, created way more jobs than expected. During internet boom and computer revolution, again the same thing was repeated. And even this time, it will be repeated again for sure. The two things which I think is essential here is reskilling and the use of transferable skills. Right? So till this time, we were using our skills to, let's say, do some repetitive task of filling a spreadsheet. Now, we have that skill of which data should go where, right? And how the data should be organized. Same skill can be used to train a model to let that model learn how to organize data. So that's the transferable skill. So reskilling and transferable skill, I don't think we need to worry about it.
The only thing I'll say to that, because I think we covered in part
30 seconds.
the adoption part and what it can replace. I'd say fear is the biggest driver to create this perception. And what I always say as a takeaway here is you have to use the technologies. Like GPT is free. Go use it. You won't fear it. It might fall in love with you. But worst case scenario, you'll realize it's a powerful tool, but you'll get it to understand. I mean, fear is a driving factor, not just to fear of technologies, right? And the way to break fear is to face it and to sit on the other side of that fear and understand where it's coming from and what it could do.
When you talk about fear, I think a lot of it has to do with the mental component and the fact that we are using parity metrics and we have all these voice interfaces to AI as we think of them as human replacement. And I think that lends to a lot of the fear that we have and a lot of the fear that workers have. The other big factor that contributes to the reskilling is the fact that, you talk about data, right? How many here are data scientists, and how long did it take you to become a data scientist, right? It takes 20 years to be a great data scientist. And here we are asking a layperson that has no idea about data to become an expert in data science. So the learning curve has to come down. So that means that we have to have a net new human-machine interface that makes these things not rocket science or data science, as this instance, but instead something that's so easy for you to do that you're not even thinking about doing it, you're just doing it. Yeah. Right.
Jay,
I mean, I'll bring it home with the simple analogy is when I think about how my own personal life has been augmented by new advanced technology, I am not disappointed that I get to take my dirty dishes after dinner and put them in the dishwasher and press the watch button.
Right, because it reduces the effort.
Exactly. Nobody's complaining about being out of that job, and I get to spend more time creating more great meals and enjoying the conversation and that type of thing.
Actually,
it could be really good.
Like another example, I just filmed my half-yearly performance review yesterday, and I used ChatGPT. It was like it used to take 3 hours. Yesterday, just to
right?
I just
Easily thought this was
put very like related data
I
just to
think we're
create
down
some.
down to our last minute, 1 minute left. Do we have one question? We can take one question.
So it's a tax on the token. I mean, it's very resource. I mean,
Maybe we can give the gentleman a mic.
okay.
So we're just going to take one because we are running over. We can make it real quick.
Because AI is a very resource intensive with water and energy. How close do you think that we are to taxing the token and how that would be vision? Yes.
That goes to the legislation question and the way that we go about with shared prosperity to these things. Both the worker needs to be compensated for the data they're contributing, and also the way that we go about paying for these systems has to accommodate what you're talking about there, how you're paying for the energy.
So we're going to let Jody's answer stand for the panel, because we're over our
Sorry,
time.
guys.
And I want to thank the panel. Please give them a great round of applause.
Thank you.
Great discussion today.